Hello, in this video we're going to look at some of the interesting relationships between marginal densities and joint densities. So let's just jump right in. Number one, let's show it's possible for the random variables x and y to have densities, but the tuple x comma y does not have a density. So let's let x have a density f of x, and let's let y, the random variable y, equal the random variable x. So note that y has the same density as x, which is f of x. Observe that the tuple x comma y is this set. It's all x and y in R2 space such that x is equal to y. Now let's denote this region by A, and note that A represents a line in 2 space and has Lebesgue measure 0. Right? There's no area on a line. Now, to be a joint density, the following must hold. The probability that this tuple is in A, that means the whole region, has to be 1. However, the probability that the tuple xy is in A is equal to the integral of the density of x and y. But since A has Lebesgue measure 0, this is 0. So and hence f of x, y is not a density because it doesn't integrate to 1. Now, part 2, let's show that the joint density of x, y does not have to be determined by the marginal random variables x and y. So here's an example. Let's let f of xy equal 1/4 times 1 plus h of x times h of y. X goes from -1 to 1, y goes from -1 to 1, where h is an odd function and has modulus less than or equal to 1. Now, note that this is a density. If we integrate f of xy over the entire region, you can kind of break it up into this piece and then this piece. That's what we do here. But because these are odd functions, this integral is 0. And this integrates to 1. So it is a density. But let's look at the marginal densities. So f of x is, we integrate out y, so we go from -1 to 1 of the joint density f of xy dy. And this equals 1/2. And this is x, but so x, is f of x is 1/2 between -1 and 1. And similarly for f of y, it's 1/2. So note that f of x is equal to f of y equal to half, regardless of what these function, the function h is. So there's no way that these marginal densities will determine the joint density. Now, number 3, I'm just going to point you to a video that I have where it's non-normal bivariate distribution with both normal marginals. And that's an interesting video too. Well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.